right, this is Mr. Hendrickson again. We're back with more quadratic functions. So we are going to try solving some quadratic equations by graphing. So the key is we're still going to graph our quadratic functions. Most of these are going to be in standard form. The one thing with an equation, it has to equal something. So we want to make sure it equals 0 before we get started, and then we can graph the function. The important thing here when we find the solutions are the x-intercepts. So at some point we want to put that those are the x-intercepts. So it's where the graph hits the x-axis. So if we can draw a picture, sometimes we have to estimate this for now if we're just using graphing. So we want to see where it hits the x-intercepts. Now there's three possibilities when we draw the quadratic. There could be two solutions when we draw the quadratic. Now this one shows an upside down one. Even if it's going the normal way, going up right side up, it could hit in two different spots if it crosses the x-axis. It's possible that you might only get one real solution if it only hits in one spot. That would mean the vertex would have to be on the x-axis, and it could go up or down, but as long as the vertex was at the x-axis, we know there's only one solution. It's also possible that there's no real solutions because it doesn't hit the x-axis. It's always above it or always below it. So there's three possibilities. Sometimes that can help us get the solutions before we even do a whole xy table to find a bunch of points. So we still need to graph these functions in order to see what they look like, and then we can find where it hits the x-intercepts, and that will be the solutions. It'll be those x values that we want to identify. So we have 4 examples that I'm going to go through, and then you can try some on your own. The first one is one that's kind of the more standard practice where you get 2 roots. You get 2 answers along the way. We have to find what those 2 answers are. So again, we start by graphing this function. So we have our quadratic function. It's in standard form. So I want to make sure I start by labeling what my a, b, and c are. So a is 1, b is -2, c is -8. Again, one thing I recognize is because a is positive, I know it's a normal up-facing parabola. That can help if the vertex ends up above it. I know there won't be any solutions. If it's below it, there'll be 2. So this is what we start with, A, B, and C. I then want to find the axis of symmetry. This is what we did yesterday. So x equals minus b over 2a. b is -2, so that's going to make that a positive 2. 2 times a is 2, so I'm going to get x equals 1. Next thing I want to identify is what's the y value that goes with that. So I'm going to plug that 1 back into the equation here, and I'm going to do 1 squared minus 2 times 1 minus 8, 1 minus 2 minus 8, so I get -9. So my vertex is going to be the point 1, -9. So I like to put that on my graph, and so if I go over 1 and down 9, I get my vertex. And I know my parabola is going up this way. The key on this is I want to find where it hits the x-axis. Now, sometimes you know the standard parabola, which way it goes based on our transformations, but sometimes it's a little trickier to figure out exactly where those points are. So this is a good spot here to make an xy table to figure out exactly where it's going to hit those points if I can find them. So for me, I like to do an xy table. I'm going to put that over here on the side of the graph. I'm going to do an xy table. So I can find those exact points. I can figure out parts of it. I know my y-intercept, if you recall what we did there. The y equals c, or in this case, my c was -8. So I know that point, and I know the point on the other side of it, but sometimes trying to find exactly where it hits is a little more tricky. So I can start filling in the xy table. Since I know the vertex, I like to put that in the middle here. Oh, that's +1, -9. That was my vertex. I have the y-intercepts, but I usually just start going on either side of the 1. So to the left of it, I get a 0. To the right of it, I'd get a 2. Since I do know those points already, those are both -8. If you need to, you can plug in 0 or 2 into the original equation and find out what you get for an answer. You will get -8 for that answer, and they both have to be the same because it's a parabola. On the other side of 0 is -1, and the other side of 2 is 3. Because it's symmetric, I'll get the same answer. So I just need to plug in one of these into the original and see what I get. So I'm going to kind of go a little quickly with that. But if I'm going to plug in 3 in there, I get 3 squared, and I'll write it on the side here, 9, minus 2 times 3, which is 6, and then minus 8. So I get 9 minus 6 minus 8. If I do the math on that, you get 3 minus 8, so that's going to be negative 5, which kind of tells me I'm still going up this way, but I haven't hit the x-axis yet. So I want to keep going. So the next point would be negative 2 and 4. And again, I just need to plug in one of those numbers. If I plug in the 4, you're going to get 4 squared, or 16, minus 2 times 4 is 8, minus 8, and 16 minus 8 minus 8 is 0, which means this one also is going to be 0. And I can plug that in if you want to double check it, but it's symmetric. So those are my 2 spots where this is going to hit at 0. And I get my 2 solutions. So the 2 solutions are the x values, so you can write x equals the negative 2 and the x equals the positive 4. Those are my solutions, and I get 2 of them. Now this tells me I had 2 in the beginning, but at least I know I'm going to get 2 roots. Those are my 2 solutions. You can finish drawing the parabola. But that's where I get my solutions. So that's how I find those values. A little bit tricky, a little more work with the XY table, but we get the general shape if I was just graphing it. Now I'm actually trying to find those points. So that's kind of nice to see them when they hit exactly at 0. There's other ones where they won't hit exactly 0, and it's a little bit trickier. For example 2, this one only has 1 root, they're going to tell us, which means if you go look at this picture, it means the vertex is going to hit right at the x-axis probably. We don't always know that ahead of time. It's nice that they put that in the problem, but we won't always know it. The tricky part of starting with this is it doesn't say equals 0, so we have to make sure we rewrite this so it equals 0 when we're doing a solution. So the minus 9, I have to add that to both sides, so I get a plus 9 in order to make that equal 0. So again, I always want to make sure it equals 0 if I'm doing a solution or finding the solutions. Second thing I want to make sure I do is find my A, B, and C. So I label what A, B, and C are. I do my axis of symmetry, which is my minus B over 2A. B is negative 6, so when I do minus that, I get a positive 6. 2 times A is 2, so I get x equals 3. And I want to find the vertex, so I need to put the y. I put that 3 back into this equation, and 3 squared is 9. 6 times 3 is 18, plus 9. And conveniently, this comes out to be 0 right away. So I get the point 3, 0. So on my graph, I know I'm already on the x-intercept. Now my A was positive here, which tells me I have the regular shape. So since I'm already at the x-axis, I really don't need to be too careful about the other points. You can do an XY table and check it, but we know the vertex hits there, so that's the only solution, that x equals 3. So it's nice when the vertex point hits at 0, because there's only going to be one answer. And it may go up or down, but it's only going to be one answer when the vertex is the 0. If the vertex is not 0, like this one up here, I need to make sure I do the XY table and find the zeros if I can. So there's 2 examples. Next example. This one actually tells me I get no real roots, so I'm going to start, I kind of have a heads up on that, but I need to see how that works out. So I still want to graph it, see what happens. And again, I go through my process of graphing. It does equal 0, so I label my A, B, and C. So A is 2, B is negative 3, and C is 5. I need to find my axis of symmetry. So negative B is going to give me a positive 3 over 2 times A is 4. So x is 3/4, which is a little bit tricky when you get fractions. It's a little hard to do the work. If you want to change that to a decimal, you're allowed to and use a calculator. For me, I'd rather keep it the decimal when I do my y value here. I want to find the y value. So I'm going to plug that in here. I'm going to kind of go through it. Like I said, if you need to use a calculator, that's fine. But x squared, so 3/4 times 3/4. So I'm going to do 2. 3/4 times 3/4, I multiply the tops and bottoms, so I'm going to get 9 over 16. minus 3 times 3/4 plus 5. So I'm going to have to do these fractions. 2 times 9/16, I end up with 18/16. I'm going to reduce that down to 9/8. Again, if you're using decimals, that's fine. 3 times 3/4, that's going to be, it's like 3/1, so that's 9/4. And then the plus 5. When there's fractions, again, I'm going to stick with fractions. I'm going to get a common denominator and make them all the same. So that's 9/8. We'll make this 5/1 so it looks like a fraction. To change that to eighths, I have to double the bottom. So I'm going to double the top. To change this one to an 8 on the bottom, I have to multiply that by 8. So I'm going to multiply that by 8. And now they're all 8s, and I can 9 minus 18, that's negative 9 plus 40. So I end up with 31/8. Again, kind of a weird number. So my vertex has some fractions in it. I get 3/4 and 31/8, which when I go to graph it, I don't have to be exact, but I know 31 divided by 8 is just less than 4. So it's going to be 3, almost 4. So I'm going to be somewhere up in this spot. Now, normally I would say we need to do an XY table to see where does it hit the x-axis. But if I go back and check, my A is a positive number. So I know the vertex is up here and it's going this way. So that's never going to hit my x-axis. If the A was negative and I knew it was coming down, I would have to go through and do the XY table and plug in some values here, which would make it a lot trickier, especially with the fractions. But this is above it, so I know I'm not going to ever hit it, so there are no solutions. So that's why it's important to know which way your parabola is going, up or down. As soon as you get the vertex, we can figure out up or down, and that'll give us an idea where our answers could turn out. In this case, there are none. All right, the last example we're doing here, this says no integral roots, which integral means there's no integers. They're going to be fractions or decimals. We do not have to get the exact answer. Some problems it'll say round them to certain decimal points. We can just say between what two numbers. So we kind of need to do the XY table, and then we're just going to say it's between two numbers. So it's not very exact if I'm doing this method. That's why next chapter we'll learn some better methods for more exact answers, but this still gives me a good idea. So we're going to run through this last example. Again, we need to graph this and see what happens. So it's equal to 0, so that's a good start. Label my A, B, and C. Find my axis of symmetry. So x equals minus b over 2a. So minus 6 over 2 times 1, which is negative 3. I want to plug in the y, or plug in that x value to find the y. So what's the vertex? So negative 3 squared is 9. 6 times negative 3 is minus 18 plus 6. So negative 9 plus 6 is negative 3. So for my vertex, I get the point, negative 3, negative 3. So I like to start negative 3, 1, 2, 3. Again, I check my A value is positive, so it is going this way. So it will hit the x-axis. This has got to have some solutions. It just, and for this one, it turns out they're not going to be exact numbers. So when I go to do my XY tables here, it gets a little tricky with some of it, but we're going to do an XY table for this. I'm going to put that over on the side here, so my XY table. And I'm going to start, the vertex was negative 3, negative 3. So I want to go on either side of that. So negative 4 or negative 2 and see what I get for an answer. And if I'm hoping to get a 0. In this case, I'm not going to get any zeros, but I know it's going to cross over the 0 when I switch, like this is a negative number. I'm either going to hit 0, or when I go to get to a positive number, that's when it switches, and you can kind of see it on the graph, but we'll try this. So I need to plug in either the negative 4 or the negative 2. I'll plug in the negative 2. It's a smaller number. So minus 2 squared is 4. 6 times negative 2 is minus 12 plus 6. So I end up with negative 2 for an answer there. So I can put those 2 points. Remember, this is my axis of symmetry. so I know I get the same values. So it still hasn't hit the x-axis, so I'm going to try -5 and -1. Let's plug in the 1. So -1 squared is +1. 6 times -1 is -6, plus 6. So I end up with +1 there, which means I get a +1 there. Which means I've now crossed over the x-axis. It didn't hit 0 though, so it's not an exact number, but it's in between these two x values. So wherever I crossed over from a negative to a positive on the y side, that's where my answer is on the x value. So I can just write between those two x values, so -5 and -4, and the same thing down on this side, I can say between the -2 and -1. So I don't get exact answers, I just say it's in between those two numbers, and that's how I can find the solutions. There'll be other ways to be a little more exact. Some problems even say round it to the nearest tenth. For now, we don't have to. We're just going to say between what two numbers if we get a good picture. Sometimes when you draw it, you can kind of tell where it's going to cross between, depending on how wide or how narrow the parabola is. But for now, the XY table is going to be a pretty good tool to find those answers. Hopefully you have a little bit of luck with that and you do this. So again, good luck, have fun, do some math, and we're good.